Okay, we're getting into chapter 3. This is section 3.3 today, other forms of a linear function equation. I'm having some technical problems, so I've got a lot of it written out already, and I'm going to fill in some blanks. If you need to stop and start again to get caught up, feel free to do that, of course. We've been working in class with the slope-intercept form of a line, y equals mx plus b, where m stands for the slope. One bonus point in class tomorrow if you can tell me why we use m for slope, and b stands for the y-intercept. This form is usually best when we graph lines, because when we graph we usually focus on this area here, which is the center, the origin of the coordinate plane. This plane in reality goes on forever in all directions, but we usually focus on this portion of it. A lot of times when we deal with word problems, we are not going to be focused in on 0, 0. And we'll have to use more real-world values, but we'll get to those later. So when you go to graph a line, as you did in class in section 3.2, if you have slope-intercept form, it's the best for graphing because you can just place a dot at the y-intercept. And by the way, this is the y-intercept because when x is 0, what you're telling your graph is, graph, I need you to set x equal to 0. So I need to know where I am when x is 0. In other words, I'm restricting myself to this area here, and then the equation tells you back what will y equal when x equals 0. So in this case, y equals 2. So we'll go ahead and get a dot for y equals 2. Let's make our dots smiley faces today. Here is the intercept. Oh, sorry, that's too big. Can't go with that. Here we go. Okay, so here's my intercept right here at x is 0, y is 2. Now I use my slope to find one other point. Any 2 points will do, but when you have slope-intercept form, you just use the slope that's negative 1/3, which is a rise of negative 1 and a run of 3. So from my initial point, I'm going to go down 1, and I'm going to go right 3 to get a second point on this line. I could have just as easily gone up 1 and left 3, but usually I do up or down and then to the right. But either one of those is just fine. And now my line, I'm going to get another few points in my head by tracing that slope just so that my line ends up in the proper location. And there we go. And that would go on forever in both directions. All of those, that line is all the points that make this equation true. So anytime you need to graph a line, that's usually the way to do it. And if you know the initial value in a linear situation and the rate of change or the slope, this is the way to go because you can put those two things right in. When I say initial value, maybe you're saving up and you've got $318 in the bank and you're trying to get to $500 for a new iPhone and you get $17 a week for mowing the grass. Well, you know the initial value, which would be the y-intercept, and you know the rate of change, and you can make a linear function for a real-world situation like that. Okay, point-slope form, named because those are the two aspects of this equation. When you know a point that's not necessarily the y-intercept, this is what point-slope form will look like. Okay, my point is x1, y1, and my slope is still m. So if I need to graph this line, I just make my first dot at x1, y1, and then I'll use my slope to find the second dot. Now notice this formula is made from negative signs. So x1, y1 is actually the opposite of this plus 1 and this minus 3 because the formula is set up for negative. So this is technically a minus negative 1. So the point that I know is on this line is negative 1, positive 3. Negative 1, positive 3 right here. Okay, now that's one point and I can trace my slope to get a second point just as I did with this example. It just doesn't happen to be the y-intercept, and that's fine. Any 2 points on the line are enough to determine that line and graph it. So I'm going to go up 2 over 3 for my slope of 2/3, and then I'm going to connect the dots. Okay, again, why don't I add a few more points just to illustrate. It doesn't matter which 2, up 2 over 3. I could go down 2, left 3. down to left 3. It doesn't matter which 2. I just need to keep that pattern going, and all of these will fall in the same line. Okay, so this form is useful if you know any point that's not necessarily the intercept. You can come up with the equation and graph the line in that way. Okay, the third form, our book just calls it ax plus by equals c form, which is the most unoriginal name I've ever heard, just because that's what it looks like. So I would sum that up as ABC form, or general form, or standard form. And here's an example: ax plus by equals c. It's not used very much. There are certain situations where we will use that, but it's not a very common one, because no characteristics of the line really show up with a, b, or c. If you have 4x plus 3y equals 12, really, if you need to know the intercepts, I just kind of made this up because I wanted to give it a usefulness. But to find a y-intercept, you set x equal to 0. That's universal among all math courses. So if I set x equal to 0, then I get 3y equals 12, and my y-intercept is 4. So I can go ahead and go up to 4 for my y-intercept right there. If I want to find my x-intercept, I'm going to set y equal to 0. Again, what you're telling your function is, hello function, I need y to be 0. I need my height to be 0, so I'm going to be somewhere along this line. Now, function, you tell me what x needs to be for that to happen. So I tell you y is 0, you tell me x must be 3 in order to make that happen. I go to 3, put a dot there. And as usual, you could rearrange this, which I'll do in a few minutes, and get the slope. The slope turns out to be negative 4 over 3. You only need the 2 points. It's easier to draw it with more, but I'll just do the best I can and connect the dots. And I should technically be putting arrowheads on the ends of all these to imply that they, or to show that they go on forever in both directions. But sometimes I get lazy graphing. Okay, so that's our 3 forms, and the skills that you need to know for this section mainly are transforming from one form to the next. The questions in this chapter, in this section of the chapter, are going to start with point-slope form, and they're going to move on to slope-intercept and then to ABC form. Okay, and one of my technical difficulties is the sound, so you're not gonna hear me for a few minutes, but I'm gonna go work this problem all the way through, and then I'll be right back. Okay, so what I did there was start with the characteristics of a line, which is some of the questions in this section give you characteristics and not just the equation. So if they tell me I've got a point and this slope, then I'm naturally going to go to point slope form, and I'm going to fill those in. Now I used to get confused with these little subscripts, the y1 and the x1. That just means this x and this y are one specific point. They are not the variable x and y that stay in the equation. So I plug -5 in for y right here. Notice again that that negative turns positive because of the negative in the formula and the negative sign on the y1. I put the 4 here, that's negative. Now to change to point slope form, it's just a couple quick steps. I distribute the 3x minus 12. Then I I subtract a 1.5 from both sides and get to slope-intercept form. Okay, one line could have a million different point slope forms because there are a million different points on that line. But there's only one unique slope-intercept form, so if you want to know if I want to know if I'm talking about a specific line, slope-intercept is the one to go with. Now, to get to ABC form, or general or standard form, I move the 3x back to the left, make it negative. I subtract 3x from both sides. And I went ahead and I made the 3x positive. It doesn't have to be positive, but I just like to start without a negative in the very front. And then one of the rules about ABC form is that A, B, and C have to be integers. So I technically have one more step to do, which is to multiply all parts of this equation by 2 and get 6x minus 2y equals 27. Now, the 6 is positive, which is not required, but I like a little bit better, and all A, B, and C are integers. Okay? So there we have transforming from one form of the line to another. Thank you for bearing with me with the sound. Young out.